Hello. How's everybody today? I'm back. I'm glad to be back. Unfortunately, last weekend I had to go out of town for a funeral, so um, wasn't able to stream. But here we are. We're going to do some stuff again with HanoiDB today. Um, Last time, if I recall correctly, we were on the verge of kind of wrapping up the structure of the internals and almost ready to start building the the public API, which is a really cool step. So we're going to focus on finishing up those mechanics that were remaining, specifically about cascading merges. We already have the idea of you know per level implementing a merge, but we kind of need to know how to propagate that down. Um, and also, each of these operations, since we're not doing the sort of independent threads slash processes thing that the Erlang version does, where it sends messages to other levels directly, we need to have that top level database abstraction coordinate those actions. So having the actions on a particular level return a set of commands that can be used to influence other levels is really important to have implemented. So we're about to tackle all of that, um, and then we can make the public API. So it's pretty exciting. Um, One major thing that we're going to try to tackle today is the computation of how many merge steps to do based on what budget was given by like the previous level, and then also adjusting to the size of the level that we're in. So that was some kind of wonky computation in the Erlang version. So we'll and we read through that in a previous episode, previous stream. But we'll go back to that now and try to interpret what's there and see if we can make some sense of it and port it. So that's all on the table today, and hopefully we'll get through most of that. So I'm pretty excited. I hope you are too. But let's get started. All right. So apologies, I am a little bit sniffly today because of allergies, um, and I have the window open because it's beautiful. So hopefully that won't be impeding too much. All right, so we have this. I don't actually know what was uncommitted, so let's look real quick. Oh, it was just a formatting thing. Okay, mostly a formatting thing. Um, yeah, so we need to resolve this compiler error. And I was looking at, well, what's this, the merge. Well, we have a to do on it, but it returns a result of vet command. Um, and the error we're getting is promote file doesn't return a result of vet command. So we need to make those line up. And we might even at some point make a we might make a type alias for that potentially. So I may call it command result. I don't know. We'll see. Okay, so when you promote a file, this is a lower, smaller level has completed a merge and it needs to move a file up into a deeper or a larger level. And so it is when we call this, it's going to take the target level and then try to promote file on that. So that level will accept this file and load it up into one of its 3 slots. And then we do have a panic here, which is if all 3 slots, given the design, it should not happen. But if all 3 slots are filled, then you can't promote something, and that means our implementation is flawed if that happens. So hopefully we won't run into that when we get to the point of actually testing this thing at a deep level. Okay, so let's save that. And it's still complaining. Mismatch types. Oh, right. Okay, so this is also going to return a vec of command. Now the challenge here is we need to, I think I'm seeing it already. Here we're throwing away this list of commands. So, and where are we calling this? We're not calling it from anywhere yet. But we are having it handle this. So it feels like we're gonna have to deal with that. Okay, so now it's just saying they're not called, they're not used from anywhere, and that's up here that it's complaining about. Those are never used. Makes sense. Okay. So I think we probably want to do this, and then we're going to say assert commands is empty. Because when you promote a file, there should be no, if it succeeded, there should be no resulting commands. We can't do that here, though. So I think that we will need to have this be, and I think we talked about this last time, we are going to, rather than doing a straight iterator, we are going to make a new one. We're going to make a vecdeck. From commands. Okay, and this needs to be mute. And then we're going to do while let some commands dot pop front. We're going to do let extra commands self dot handle command. Okay, and then we'll do commands dot extend extra commands. And then this will, and I need to make sure that that's imported. Let me see. No, it's imported. Okay. The reason I'm doing a vecdeck is so that we can handle them in order. But if there's a case where, and the plan is yes, where merge causes a new merge or promote file or combination thereof, then we need to put all of those commands into the queue to be processed. Another option could be that we do this recursively, and that if there are any extra side effects of handling one command, then we handle its side effects immediately. I'm not sure about the implications of that. So let's put a to-do in here. Should we handle additional commands immediately in a recursive fashion? Okay, because there could be a case made that if the commands produced here are promote and merge, that those should be handed off to the next level immediately. But I think that we're probably okay for this as a first pass, and we'll try to address that later. See if it's even needed. Maybe we could make like a prototype with one and a prototype with the other, and see what the differences are. Okay, so okay, yeah. So here's our big to do from last time: implement all of this. So let's take care of this. We're going to need to we create the merger lazily. So let's go ahead and do that. Yeah. So if we get an instruction to merge, we should do self.maybe create merger. Okay, so that's our first step. And I think that if self.merger is none, we return okay with an empty vec. Because there's no merge work to be done on this level. Now there is an argument to be said, and maybe when we get to figuring out the computation of how much merge work should I do, that even if this level doesn't have any merging to be done, it should propagate that work to the next level. So we'll put a propagate the steps to the next level. Level question mark. Okay. So let's take care. We're going to remove this to do. And we're going to say let mute commands is an empty vec. Okay, so what we're going to do is we're going to call merger All right, I'm going to maybe switch this up, because what we want to do is we want to do if let sum merger mute is self.merger.asMute, right? So this will let us get the merger as a reference. Else we'll do this and we get rid of the okay. Oops. I don't know, I keep triggering that lately. Let's just do this, and then we'll put this inside the body of this if let. Okay. So put these comments up here. And for now, we're just gonna, to satisfy the compiler, we'll say we know we want to return commands at the end of this, even if we haven't modified it. Okay. So now we need to do merger dot incremental merge, and we need to give it steps as usize. And I think we talked about this last time, potentially, as something where we would make it I32 all the way across. Because I don't like unnecessarily converting these primitive types, even though it's probably safe because usize is going to be 64-bit. Now, if I32 is negative, who knows? So we need to think about that. And this... Okay, so... okay, so we need to do this. And this is new merger. None. We do nothing. And let's convert that into an if-let. Now, there's a problem here. Because we implemented this here, let's put it back to this, because I think what we want to do here is, you know, if the merger closes, then we want to do, and we're going to have issues with moving, and I need to figure that out. And possibly what we do here is, rather than as mute, we do take. Right. So then the T is owned there, and it replaces it with a none. Yeah, let's do that. Okay, and then it's moved, and then we can use self.merger. Replace. Okay. And now here, you know, we'll figure out what extra work we need to do because we didn't complete the merge. But since this is none, we definitely need to put commands.push. That means the merge completed. And I think we need to figure out what that file is. And we didn't store it there, right? We just have a writer. But let's see. We need to return a promote file. And the path needs to be do we have all that information? Yes, we have the path and the level. I really feel like I should make a, let's make an internal function for this, because this is getting repeated a lot. And then say data file name, and this is self, and the we'll call it prefix is a stir, and this will return, it'll actually return a path buff. So we're going to copy this, and we will replace format, and this is going to be prefix. Okay. So let's go ahead and replace this with that new thing, data file name and A, right? And we'll do the same thing down here. So this one is going to be B. You know, I'm still not happy with the copy pasta in this method, but we will have the opportunity to clean that up at some point, I think. I don't know whether it's valuable to clean it up, to be honest. Okay. So path is going to be data file name. And it's going to be X is the prefix, because that's what the merge file is. And the target level is going to be self.level +1. Okay, what's wrong there? Path. Okay, we need a... These both need to be unit. There's probably something other than replace. Is it just like insert? We don't need insert. I mean, replace returns the old value. Yeah. Replace is fine. I mean, insert is... also okay. We just won't do anything with the reference that's returned. Yeah. So interesting that one doesn't have must use on it. Okay. Okay, so that's a little bit better. Now that we have this data file name for this level, and we've got that up here. Okay, and so we can probably do the same thing up here, except that that requires self. Maybe we change this to level. Level is a U32. And we do that. In which case we don't need to, since it's no longer self. Just trying to make sure that we have the opportunity to use this like so. This is C, and this is B. I don't know if you're gathering this, but sometimes you don't know what the API is going to be until you try to use it. And this is definitely one of those cases. And this is level and A. You know, again, this is a bit repetitive. Maybe we could have something that loops through, you know, and those should not have commas at the end. I probably messed that up down here. Yep. You know, and checks each one of these. This is C, capital C. Okay, and that should not be self.level, but level there. This could also be a private function inside this module that's not associated with this struct. It's okay though as this, I think. Oh yeah. So that's not going to work. Here, let's back that out. I forgot you need the path as well. At which point, maybe what we do is let's make one that is has a path, that's just path buff, and then we will have yeah, let's move this out. And then we can also have one in here called data file name. And that's going to call self and prefix stir. Again, you never know. And this is self.path. And that can actually be a reference. Self.level, right? Yeah. Okay. So now, oops, we can go up here, and this can be replaced with data file name, and that's path, level, and then A. And that's the module level 1. And this is going to be B. And this is going to be C. And then these can use the self version. And yeah, we can remove that. And this is a local method, not a type level method. Okay. So, yeah, it's fine. Don't clippy or allow. What's the warning there? Okay, what's the warning? I need to fix that. All right. Hi, Isaac. How are you doing? I'm doing great. Happy to be back. Okay, now it's just complaining about never used. But that's not strictly true. What I want there is path buff. I want its join method, unless that is a deref. A derefs to path. Does path has join? Path has join. Okay, so that's what that's complaining about. Now it thinks it's never used. Okay, so so we figured out when the merger does this many steps, we still need to possibly look at computing what the actual steps should be based on this level size But if it closes the merger, we know we can promote the X file to the next level. So we've got that much done. And here we're going to see merge is incomplete. Put it back into the struct member. And in this one, we know, I'm going to have to wrap this up so I have comments. And semicolon there. Here we know that merge completed, the X level file is ready to be promoted to the next level. Yeah, thanks, Isaac. I'm really glad to be back. All right. So, okay. There's another bit here that we need to do when the merger completes, and I don't know if we did it here. Right, we did not. So we needed, now that those are merged, we need to remove the A file and the B file. So, and we need to, there's a couple steps here, if I recall correctly, in the Erlang code. I don't know if it's in merger or if it's in the level. No, we're not talking about range folds yet. Right. Okay. So here it is. When a merge is complete, then oh, interesting. The outcome emerging resulted in a file with less than level entries, so we keep it at this level. Okay, so there's a step where they're closing and deleting A and B. And if C is present, right. I don't know that this comment is accurate, because it looks like what it's doing is, I don't know where this out file name comes from. We're going to have to look at where this message is generated. There's some other mechanics going on here that we're not clear about. Because there's recovery for each of the levels, and we're not handling recovery for the levels yet. Okay. So this is where I think this comment may have been attached to this clause originally. And now it's on this one. That's not clear. I'm not certain about that, though. We're going to have to dig into this a little bit. But essentially what they're doing here is if if the merge completed, you want to close and delete both of the A and the B files in this level. And then you move C, because it was the newest one, you move it into the A slot. And I don't know why they're deleting this file. Not clear to me. Yeah, okay, so if a merge is not, I'm guessing this is merge is done, but right. Rename the temporary file to M so recovery will pick it up. Then delete A and B. Okay. Then rename M to A. That's interesting. And if C exists, then you move it to B. And you reopen it. If not, you've got the M file is A. So I don't know what's going on here, exactly what condition this is. Because I really think this comment belongs with this clause. Because that's saying that... Now maybe this is the case where when it merged, there were no entries at all. Which I guess could be possible if you have expiration. I'm not sure. Question, can you undo file deletion in Z already? Absence of this feature is no, I don't usually delete files using the UI. I'm not sure if you can undo that yet. There is a difference between trash and delete. I'm not clear. I think trash puts it in the system trash, at least on Mac. I'm not sure how you like, I don't know that you can undo delete. I mean, have a good backup. I haven't run into that though, because I almost never delete using the user interface. Almost, if I'm deleting something in my code editor, I will probably do it from the command line, because that's just how I work. Your mileage may vary. Okay, so I think in essence what we want to do is this bit, and if C exists, rename, like close it, rename it, and then reopen it as A. And I think that's what we want to do. Let's get that done. And I there's some bits here that I'm not completely clear on, where we might want to handle this particular case. So maybe let's just look for where merge done is generated. Multiple places where we're receiving it, it looks like. We need to push the output of merging to the next level. This is the promotion thing that we talked about. Okay. If the next level is undefined, then you open a new level. Now we went the route of from min level to max level, just open them all. And they just might not have any files in them. So that's sort of a structural difference here. And then there's some message being passed here to whatever owner is of this current level state. Okay. Right, so no need to remove it, simply doing it injects, and it's just inject the file. Okay, so this is interesting. So these are two cases. This is the case we've actually just implemented, regardless of the count here. So I think that we need to possibly have the merge operation. So when we pass in the incremental merge, rather than returning result of option itself, it might return it's going to need to return either self here or maybe it returns an enum of like continue, like a merge result or something. Just spitballing. Maybe there's a merge outcome. I don't want to use result because that's too close to this the result type. Maybe it's a continue, so like it wasn't closed, or complete, and then it has an idea of how many keys are written. Let's say count usize, something like that. And then we can, let's go to the writer definition. Right, so this may be what's useful for, so if we say count before we close the file. So the other option is it could be a result of option of usize. The difference here might be that we need to because I still feel like we need to consume this, but if we don't consume it here, if this is like so, and this is okay none, and this is usize. Fine. Yeah, and that's the problem with close. So let's back that out. So I think we're going to do the other option is we do yeah, maybe this is merger. Okay, we're going to rewrite this. What I'm trying to get around here is we need to know how many keys, right? So if the merge made a file that is not big enough to go into the next level, we should put it into this level, if that makes sense. And I think that's what that code was trying to do. Okay, so instead of this, instead of result options self, we're going to have a merge outcome. And here we're going to say let self.x.count. Okay, and here we're going to say complete merge outcome complete count. And then here, rather than sum self, we're going to say continue self. It could feel a bit like this is, overkill. Maybe I pull in either type. I don't know that I need to derive anything there. But honestly, it's a very small thing. So now we need to go back. Right. So this is continue. Merge outcome continue. Right. And this is merge outcome complete count. Okay. So we need to know whether this file has enough keys to be promoted. So level, U32, and usize. Okay, we're going to say level as usize, and we're going to do 1. Is that correct, or is it level -1? There's this macro, btree size. Yep. Okay, so given a level, bit shift left, that many, that gives you, yep, okay. So, I'm just put inline. There's no reason not to inline that. So what we want to do is if count is greater than or equal to level size, so if it's bigger, right? Because over here, where were we? Merge done. Right. Okay, if it's 0, we just delete all the files. The merge file didn't matter. Okay, and if it's less than, okay, now I understand why this is renaming it to the M file, so it can recover if it like crashes in any of these lines in this step. Okay, so this is saying, interesting, these extra conditions on here. So we were mostly looking at, is this smaller than the size of the current level? But also considering whether the C file doesn't exist. So if the C is undefined, and next is undefined, so next is the next level in the tree, in the forest, which means that either that level doesn't exist, or we're at the top level. Okay. Okay. So maybe we don't handle this case right away. We definitely need to handle this case. So let's... So if it's 0, then we need to... so if there are no keys in the resulting file because there are no tombstones, there are no values, then we need to close out those two files that were merged. So close and delete A and B, and maybe we make a method just like they did. Close, it's going to be verbose, delete A and B, and this is going to be mute self as a result of empty. Okay, so we're going to say is there a close method on these? On tree? There is not. Interesting. Okay. So honestly, we probably just drop. Because when you drop a file handle, it closes the handle. So we're gonna remove those. So we're closing those files. So A and B will be none now inside our level. And then we're going to do standard FS. Okay, so we'll do remove file. Now, the problem is with just straight doing that is if the file doesn't exist. Now it should for us to be able to get into the state because we just completed a merge. And we could put is sum and self.b.isSum. That way we have a little bit of a safeguard here that that those files were open, and we shouldn't have so we're going to remove A and we're going to remove B. Let me make sure there's nothing in option other than take. I guess like moving it and dropping it is the correct thing to do. Yeah, it doesn't look like there's any other option there. Option, haha. Okay, so okay, so we need to do that. The other possibilities that we could do remove file dot and then remove file B, you know, etc. Map. This is fairly clear though. Okay, so now we can close A and B. needs to return that. And then if self.c is sum, we need to okay, interestingly, because it's a tree, the thing is, we need to, for safety, probably close it, because if you rename the file while it's open, I don't know what the behavior is. So for safety's sake, I think we probably need to take C out. So we're going to take C, and then we know that we've dropped that open file handle. So then we'll do rename. Okay, and this is self.data file name C to self.data file name A. And how did we do that over here? Right, from path. Tree from path from file. Okay. Okay, and then we need to if C is less than or equal to level size self.level. Okay, so this is the other case. We need fat arrows there. And C is probably not, let's just call it count, because and then the last case is we just promote. So here we need to promote, but we also need to close and delete A and B. Okay, this got more complicated quickly. So if it's, let's look back at what they're doing in the Erlang code here. That's kind of weird, because I actually want to drop. Okay, that's fine. Okay. Thank you, Clippy. I don't usually say that. Okay, so the merged file is small enough to fit into this level. Okay. And this is when we don't need to, this comment doesn't help because that's what the name of the method is. This file merged into 0 entries. So clean up. Okay. Okay, now we're going to do this dance that they do here. So we're going to rename here, possibly ready. So if it's small enough to fit in this level, then we're going to rename it to from X to M. Okay, so this is about handling recovery. Yeah, and that's the thing is if we crash when we're deleting A and B, C will become the A file. Okay. Interestingly, it says consider recovery for this. I wonder if there was an idea of if this merge between A and B, because it's always between A and B, results in a file that's small enough to stay in the same level, then you might have a case where, still those keys and values are not newer than the stuff in C. They were written first. A and B are always before C. So you merge them together. If it doesn't get promoted, that it should be the A file, right? So we need to, yeah, it's possible that like there could be a case where you say, in recovery, if there's an A and a C, then move C to B. Or maybe they might have been saying, if there's a C file here, move it to M. But I don't think that's what you would want to do. Because that would imply M, was the file in the midst of this rename dance. Okay. And then we're going to close and delete A and B. And then we will do this dance. Rename it to A. And then we're going to say self.a, replace. And we'll do tree from file again. And maybe we need and this will be let M is that, just so we can reuse them. I'm not actually that concerned about that, but it's a little conscientious to do that. Okay, so then we've replaced A with that, and then we need to do this thing again, right? Except we'll rename it to B. So let's copy that. Okay. And we have a mistake here. C is not reused. We want to open A. Okay. Right? Because we moved C into A. Okay, and then this is fine, but we need to extract this because we're not Okay, so now C has become B. Okay. I think we've handled the cases that we need to handle here. That was pretty cool. So now we need to figure out this stuff. So if there's still more merge work to be done, trigger the next level. So when we're getting maybe we need this continue. The other thing that is interesting about accounting for how much work was done is I think that there's let's find the merge stuff in here. Yeah, step done. Right. So here's accept step anytime there's not an outstanding step. Okay, so let's jump to do step. Okay, here's the calculation of how much work we should be doing. And I think that there was a bit where at the end here, right, so it's telling the merger here, do a step, here's how much work. Here's all the computation about how much work to be done. It's up here. We'll go back to that. But the merger, I think sends, right, so it uses this ref, and I think it sends back how much work it did. So let's look at that. No, it just says step done. Because if there's less work to be done to complete the merge than the number of steps given, then I would expect it to be sending back a no, but I think that comes from the if there's not enough work to be done, or there's like more work asked for than was actually done, it's actually just going to close the file, right? It's going to complete the merge. So we're in this one. So what I'm wondering is maybe we put another field in here, which is like remaining work or something. But let's look back at what the computation for how much work should be done based on the step size. And there's previous work, so this is like here, do step. Let's find all the places we call this. So that's previous work. So on begin incremental merge, zero step size. Okay. Except step, there's not any. There's anytime there's not an outstanding step. So where is this step level sent? Oh yeah. Okay, so it's down here. Let's go to that. Please just let me jump to the line. All right, well let's go back here and go to 706. Okay. No, that's not right. Why is it 704? Okay. All right. Hi, Greg. I'm a little bit intimidated. Um, Thanks for the challenge. Yeah, I'm gonna get back to your message and recall what the challenge is. I've been a little bit distracted with other things right now, but we're gonna compute this. Interestingly, we're gonna need access when we decide how much work to be done to what the max level was. So that's interesting. Maybe what we were passing to incremental merge in our code is not just steps, but maybe there's some configuration or something there. Min level, max level. Now, we weren't tracking in our level struct how much work was done. So that's interesting. Okay. If B exists and the merger exists, work left here becomes minimum 0, maximum 2 times the B tree size minus the work already done. Okay, so I'm guessing this is just estimating how much could be done. The okay. Okay, so this is current level or whatever the max level is. And top level is a macro definition. So yeah, I think that we made this over here. We made this configurable min level and max level. Yeah. Okay, so basically, the gist of this is there's some previous work done potentially. And that previous work comes from lower levels, as we saw in that step level message where it's sent is right here after we finished, like, hey, I'm telling you what the step size is and like how much I did, and that's passed to the next level. So this always starts with 0. Now there's also this work done here in the state of this process. So yeah, we'll have to think about that. Okay, so then the total amount of work you want to do is the step size times the depth into the tree. And then you subtract how much work you've already done from that. So let's say, for example, one level does 128 merge steps, and the step size is like 512, and it sends it up to the next level, and it's going to go, well, I can do up to 1024. So let's say that's the bottom level. I can do up to 1024 minus that 128 that the previous level did. And it does some work, and it's like, okay, I did this many steps, and it passes up, and then so you're growing the amount of steps you can do, but maybe you don't need to do. Maybe you close the file, and that gives you an idea of how many. Yeah. Okay. Yeah. I think I'm kind of getting it here. It's still kind of a complicated computation in terms of understanding where all the factors come from. But let's go back in here, and I think what we want to do is let's do steps here, because we need to know how many steps we took. And the assumption here is if we didn't complete the merge, then we took as many steps as were allotted. So this is steps is going to be self.n, right? That's how many were left over. Actually, we'll do work minus self.n, right? So that's how many steps we took this time around. Yeah, I think that makes sense. So if we took like 100 steps to complete the merge, then and we were given 512. This is how many steps are remaining, not how many steps were consumed. This isn't right. Because at the beginning here we add work to self.n. Which we assume in a lot of cases is going to be 0, right? Because we're looping here while it's greater than 0. If it hits 0, we terminate that loop. If there's no more work to be done, yeah, I don't think that there's a case where we enter this incremental merge where n is greater than 0. Because if we did, then that would mean that there were leftover steps from last time and there was no more merge work to do, but we are consuming the merger here. So I think the answer is how many steps did we take? It is work minus self.n, right? And I might even put an assert in here because and hopefully this string on the assertion right, because now we are saying that honestly we can do this, right? At that point, because we know it's 0. And if we complete all the work, then The other option is we could go do a loop here rather than a while. We can remove the n. That's something to think about, because if this n is dependent on how much work we're given, we could go 0 dot dot, for I and 0 dot dot work, and then we will know the number of steps that were taken when we early return, based on what that count is. And we don't have to do this saturating sub garbage. It's not garbage. It's necessary for the original design, but maybe that design is not necessary in this case. Maybe that state we don't need to track because it's always going to enter there as 0. So let's remove n from the struct. And then let's do we're going to change this for I in 0 dot dot work, and steps is going to be I plus 1, and we can remove that. That feels a little bit better to me. Then that counts actually how many steps we took. Okay. And then if we go back here, right, so we need steps. And this is where so regardless of how many keys exist in the completed merge, what we need to do down here is we're going to push command merge, and let's call it yes, let's call it completed steps. So we need to do minus completed target level self dot level plus 1. Now this is why did I do that? Why is that I32? Does it have to do with, no, that's usize. Why is that I32 there? Let's turn that into usize. I don't remember why. And we probably have a problem over here. Okay. Why is self.step a usize array, an I32 over here? I don't know. Change it to usize and see what happens. Probably going to break some things. Okay. Yeah, there's no reason this shouldn't be usize across the board. It's like counting things, right? I32 in this case, I would guess if there's a case where we were going to subtract, but I don't think that we're doing that. So we don't need to convert it anymore. Again, that was a weird bit. Okay, and we've got a bug right there. Okay. Now there's a question in my mind about whether we should push the merge on the front, like if it matters what order that happens in. I'm not sure. Okay, so we actually handled situation B here, right here. But we need to determine based on this, and it's also, we need to change the signature here, so it's like this is steps already done, and there's also a step size thing. And we need to handle that. That is a thing that I was kind of blind on before. But conceivably, if we did a merge based on what we have here, you know, it's not going to do the correct number of steps, obviously. But if we did a merge from the top level, you know, so if we filled up the nursery and the set of steps were triggering an incremental merge, then this would propagate to the first level and it would try to execute. So yeah, I think we're in. Okay. So I think we probably even remove this, but we need to rename this. Let's change it to work completed and step size. Okay, and then we can in here do our computation of how many steps we need to take. And when we're doing handle command up here, okay, so steps, so this steps is work completed, right? And then I'm just going to make a constant at this level. Or did we do it up here when we put the nursery in there? What did we do in the nursery for the min steps to merge? Min level size divided by 2. Okay, so we have that over here. We can do the step size is going to be self.min level, and this will be no, not in there. I need to make this pub crate. Level size. Divided by 2. And we need to import that. Again, I'm not sure why these are U32s. Oh wait, that's a U32? What am I getting wrong here? So let's say step size. Let's compute it at the top here. Before we mutably borrow. Isn't that fun? No, by 2. Okay, and this is step size. Okay. I think that accomplishes how much work to be done. We need to compute this. Oh yeah, that's very possible, Isaac. Somewhere the file format used to use 32 and that propagated. Very possible. At some point, I will want to do an audit of all the as things where I'm converting types, and make sure that we're not doing something silly, something foolish or dangerous. It's a bit of a disconnect here where like the Erlang code doesn't care what type it is because it's just a number from the Erlang code's perspective. It could be a float or an integer, but it can treat those equally. You can even add those two together or subtract them or whatever. But we have to be stricter on types here. And Rust is using usize for all the things that are like counting things or indexing into slices and stuff like that. So I prefer to use usizes wherever possible. Then you're using the native type as well, and you get some benefits from that. But yeah, there may have been a part of the file format where we used a U32. Okay, so we need to compute steps, and I think that's probably the last thing that we'll do today. So we've got we're not going to consider this, so we'll treat that as 0. The interesting thing is here, we are not going to enter this unless the merger exists. So like that means that B exists, and in the case we have the merger. So that is not, we don't need to check that condition once we're inside here. Now I should look in this file state.work done. Okay, so it's just accumulating how much work was in progress. So let's see where that work in progress is set. Yeah, set to 0 there when the merger goes down. This looks like at the end of the merge. Yes, absolutely true, Isaac. It says usize is nice. You just have to be careful of the boundaries of your program and do proper conversions and bounds checks. Absolutely. And we will probably run into some of those problems later. Okay, so this comes from the work to do here, which was computed up here. Yeah, and there's issues where, okay, they're talking about aggressive deletes with expiration or tombstones. Yeah, and I'm very sorry. I need to pause for just a minute, and I'll be right back. Need a bio break. Thank you for your patience. Thought I was going to get all the way through without needing to go, but here we are. Okay. Okay, let's see if we can get these both displaying so we can kind of translate the logic, and then we'll pare it down to the minimum needed. Okay, so the idea here is that I think we might need to track how much work is done inside the level. Because the essence of this is assume that the A and the B files have no overlap. So if you were going to complete a merge of those two files, you would need B tree size for this. So like how many keys are in each file times 2, right? 2 files. And then we're tracking how much work actually was done. So we kind of have an estimate of when this will finish. Okay, so let's go ahead and compute, and we will name it the same thing, but we will not initially handle how much work was completed, because I think that if we get to this continue thing, we can assume it did this many steps, right? And that can be added to how much work was done. So here we're going to say this is level size self.level times 2. Okay, so that's, and we'll put a to do here, track how much was actually done previously. Okay, this is just renaming, so maybe we go ahead and rename this work unit, and then we don't have to assign it separately. I don't think step size is used anywhere else in this function. I think it's all work unit. Well, it's passing it along. Okay. But we are computing that in the thing handling the command, so we don't need to pass that along. We're not passing stuff directly. We're not passing that directly on to the next level. It's passed through the database abstraction. Okay, so the max level. We either need to pass this in, or this needs to be part here. Yeah, I think we need to pass that in. So we're just going to add a parameter here. So max level is going to be U32, just like this. So our computation is consistent there. Min level is going to be U32. And again, that's more about computing the depth. Okay, let's go make that pass it in. Self.min level, self.max level. Okay. And now, yeah. It is really weird to me that it's complaining about that and when those are copy. But here we are. Okay. Fine. Make the compiler happy. Okay, so we know work unit is this. We have min level and max level. So let's do let max level, and this is weird to me. That is necessary, because if you're at the deepest level, like the largest level, they'll be equal. Otherwise, you're going to get that. But I don't know a case where this will ever be greater than that. Let's put it to do greater than max level as configured. Okay, so we're going to leave that out for now. So depth. Top level +1. Okay. So like this would be 0 at the no, it would be 1 at the bottom level, right? Okay, so max level minus min level plus. Okay. So we will say steps depth as usize times work unit. What is dash question mark? I'm sorry, I don't know which part you're talking about, Isaac. Oh, in the Erlang code. Okay, so question mark followed by any identifier in Erlang code is a macro. So it's like a lexical level macro, similar in some respects to C macros, like pound defines. So if we go here, you can see top level is 10, and that's just saying smallest levels are 10 or 1024 entries. So that's what that question top level is. Yeah. Sorry, that was not clear before. Okay, so this is like, say we have 25 minus 10, that gives 15 plus 1, 16 is the depth. So okay. We will want to make sure that the step size makes sense. And then yeah, right. That is the only. I was about to say that's the only thing like that in Erlang, but yeah, it's just a straight level source substitution. So you can do a pound define for anything as long as that is a term or is a valid set of tokens. It is possible, I think, to do things where you do like it contains valid tokens but not valid expressions, but I don't recall exactly. I think it has to be a syntactic construct. Has to be a complete one. It can't be like open parenthesis 1 BSL and then nothing. I don't think that works, because it has to know where to end this pound, this define. So anyway, but you can do crazy things like, have parameterized ones where they do stuff like this. Yeah. And in some cases, this is like, compile time feature selection, that's that sort of thing. And of course, constants, like in the Rust code for this, we made those constants in the format module. Okay, so I think we've gotten here. Let's just put that back at max and that at max. I think we've gotten here the essence of this computation. So maybe what we do is oh, right. But we need to subtract previous work. So work completed. So again, this is like gradually eating up the budget, but trying to do more as you get into deeper levels of the forest, right? And why did I not use that? Okay, work left here. Oh, right. Okay, so we actually need, let's use the name here. This is work units left. Work units left. Right, total work minus previous work. And then we need to assign steps based on, this is be the work to do here. Oh, the names on these. Greg, help. Okay. Okay, so this is going to be min of those two values. So work units left, min work left here. And this is the fast merge strategy. Then, the predictable thing maybe we'll address later. So I'll link to that. Yeah, I know naming is hard. And honestly, y'all were doing your best here. It just took me a while to parse all of this and understand it. So it would be nice maybe to think about documenting what all of this means a lot better. And maybe I'll do that. Okay, so I'm going to link to this issue. This assumes the fast merge strategy as opposed to the predictable strategy. See that. Okay. Okay. So the other thing here is that there's also a counting of how many steps were taken. Clamp work units left to 0 when negative. Yeah. So we probably want to do that's a good point. This should be like saturating sub potentially. Let's do that. It's still going to be U size, right? But we'll do saturating sub. And that way, if work completed exceeds work units left, which I don't think it will, but if it does, then we go to 0. Okay, the other thing that this is doing is it's tracking how much work actually is going to be done, and then adding that up to the existing work completed. So yeah, saturating sub is good. Good call out there. And maybe I should, think about these things as well. Make sure that these, don't overflow or underflow. Okay, so now we know how many steps are going to be taken, and we want to do, let's just call it what they call it, including here, steps plus work completed. And then that can go, interesting. So that maybe overtakes, or rather, if we do, yeah, Erlang code had max 0, right? Which is the same thing. So if we consumed all the steps, I think we still want to do pass this along, right? And we need to reconsider this. Right? So this means we didn't consume all of that. But up here, when we consumed all those steps, we want to pass along, hey, you should try to merge the next level. So and this will be work including here. And target level self.level +1. Okay, and then we need a little safety check here, which is right, because we don't want to get anything to go above that max level. So we can't merge into something that doesn't exist, because this unwrap will panic. But we also, at that point, need to handle and maybe we need to warn here. And I don't have any logging built into this, so yeah. I guess we can I don't actually want to warn there, because if we hit the top level and it's like, hey, go ahead and merge, I'll just put a note here. I don't know that this is a case we need to warn about, because if we're propagating all the way down, this is some complicated logic. I feel like I should put this in a separate method. The thing is, though, there's a case, I guess. There should be a case where we come out with steps are 0 because we consumed all the budget, right? So let's say, right, we only want to propagate this if there's work that will be done, and I think that that's what this code does. No, it only calls the merger if work to be done is greater than 0. So we could potentially then there's nothing there, right? If there's no work to be done, stop propagating merge commands, because otherwise, if we do some work and we haven't used up all the budget, then we do want to promote to the next level. Or not promote, we want to propagate the merge work to the next level. I'm not really happy about that. It feels like I'm handling this problem in multiple places. I feel like maybe this stuff, because that's a lot, I mean, that could be moved out into, what's this else? Where's that? If oh, that's this if let. I'm going to say no work to be done. If there's no work units left, if there's no merge budget left, right, then we'll just handle everything that was in the queue of commands and then stop. Okay, otherwise, if we are able to complete it, then we should say, yeah, here's how many steps we took, and next level, right. Okay. All right. I think, I wanted to get started on the public API, but it's okay. We will do that some other time. At the top. This is a potential thing. I'm on the fence about whether we should warn about this, because this says imminently you won't be able to add more keys to your database. If it's like, hey, we're trying to merge and there's merge work beyond the deepest level, beyond the largest level, then that's a problem. Okay, let's let's make sure that there's no compiler errors. We need to deal with warnings. Some of them will be dealt with as we develop this some more, and we won't have the dead code things. In fact, I'm tempted, just out of curiosity, to see right now if I go up here and do at the crate level allow dead code, and yeah, we're down to one warning. Yeah, large size difference between variants, that's understandable. I think that because this has to be a consuming thing, that makes sense. If we could change it to not consume, and like that will require us to be a bit more conscientious about closing. Yeah. Yeah, that is a big difference. Okay. Well, I'm going to remove that from here. I just wanted to see how many warnings went away. But obviously we're not exercising it because it's our main function in our app doesn't do anything. So, or it doesn't exercise those paths yet. We will need to get to that. Okay. This is session 11. We're doing more incremental merges. What is the plan for testing? Yeah, that's a good question. So my plan is to do. I will do some benchmark type tests. So like we'll probably pull in criterion or something like that. I will want to do some integration level tests with like quick check, make a little stateful model, which I'll have to refer to Nick Marino's way of doing that, because we'll want to check. You want to do stuff like issue a command, which is get or put or delete or whatever, and then have a simpler model, like maybe just a B-tree map or something, and compare the two, and try to generate big, big tests. Yeah. There's also probably plenty of places we can do unit tests. So, for example, the writer is a good thing that we could probably write some simple unit tests on, because it's kind of independent. It's got it basically just it's given a file, and then you see, does it write it, and then can you read it back. That's probably a simple thing to do. Yeah, unit tests on the nursery probably as well. There's plenty that can be done there. The merger, perhaps, that might be interesting. So use the stuff for the writer to generate the two files, and then create a merger and just have it do everything, and see what the contents of the new file is. So that's that. Those are probably fairly straightforward kind of functional tests. Yeah, I think there's a lot of space for testing here that we haven't explored at all yet. And then of course, integration level tests, looking at the public API, which we will start to implement hopefully soon. So thank you all for sticking around. I'm sorry for the interruption there. And I will hopefully see you all next week on Sunday the 13th. So have a good one, and we'll see you later.